Okay, let's try to do example 7. Okay, after the sun exhausts its nuclear fuel, its ultimate fate may be collapsed to a white dwarf state. Okay, ni statement saja. In this state, it would have approximately the same mass as it has now, but its radius will be equal to the radius of the Earth. Calculate the gravitational potential energy associated with a 1 kg object at the surface of the white dwarf. So apa yang dia nak cakap kat sini? So we have a sun. A sun dia kena nuclear fission I think, and then it jadi white dwarf lah. Okay, dan tak perlu tahu pun white dwarf tu apa, tapi white dwarf ni dia cakap it has the same mass as it has now, iaitu sebelum ni dia adalah sun kan. So mass of white dwarf ni is still the same mass of the sun lah. Okay, tapi dia punya radius adalah radius of the Earth. So radius adalah radius of the Earth. So this is your white dwarf So this is your white dwarf, this one. And then dia cakap, calculate the gravitational potential energy associated with 1 kg object at the surface of the white dwarf. So we have a 1 kg object over here. And then we want to find the U berapa. So just go ahead and use the formula, which is U equals to negative GMM over R, whereby U ni, G ni constant lah. Don't forget to put the negative. And then mass of the sun, which is, dia dah kasih kat sini, guna saja. And then obviously mass of the satellite, which is 1 kg, over R, planet ni mempunyai radius sama macam Earth, which is, this is actually radius of Earth lah. So 6.37 darab 10 kuasa 6. Okay, so kamu akan dapat negatif 2.08 darab 10 kuasa 13 Joule. Okay. Right, let's try to do example 8 pula. Okay, let's read the question Okay, example 8, the moon has a mass of sekian and a radius of sekian. Okay, a probe of mass 100 kg is dropped from a height 1 km onto the moon's surface. Calculate its change in gravitational potential energy. So, apa yang berlaku kat sini? So, mula-mula kita ada moon, and then we have a probe of mass. Dia cakap from a height 1 km. So we have probe of mass ni satellite lah. So dia cakap 1 km from the moon surface. And then dia pun dijatuhkan. So bila dah jatuh, so now dia dekat atas surface of the moon lah. Okay. And then we know that this is initial, this is the final. Okay. So dia nak change in gravitational potential ni. So obviously delta U, which is U final minus U initial. So kamu kena kira lah satu-satu berapa nilai U initial, berapa nilai U final. Okay, let's try to do this. Okay, so U initial would be negative GMM over R. So masukkan saja, jangan lupa negative sign. So mass besar lah mass of moon, which is 735 darab 10 kuasa 22. And then mass of probe of mass ni, which is 100 kg. Over R is always from the center. So maksudnya 1 km campur dengan radius of moon, which is 1 darab 10 kuasa 3 campur 1740 darab 10 kuasa 3. Okay. So I think you should get sorry, okay, tak apa, it's okay. I think you should get the value here is I think it's 281.59. Sorry, 2.8159 times 10 power of 8. Okay, Joule. Okay, and then try to calculate U final, which is negative GMM over R, ataupun will be, sekali kat bawah ni tak muat pula, negatif 6.67 darab 10 kuasa negatif 11 sorry, 100 over R is from the center. So hanya radius of the moon je lah, which is 1740 darab 10 kuasa 3. Okay, I think you should get negative 1.62 No, it will be negative. Cuba tekan kalkulator confirmkan balik. Okay. So, masukkan saja. U final kita adalah negative 2.8175 times 10 to the power of 8 minus negative 2.8159. Okay. And then your answer should be negative 1.60 times 10 to the power of 2 joule. Okay. Right, kita try double check the answer. So, this is A. And then dia cakap, B, if all the gravitational potential energy loss, which is this one, is converted to kinetic energy, calculate the speed at which the probe hits the surface. So, dia nak bila satellite ni turun bawah, berapa dia punya velocity. So, dia bagi hint kat sini, semua potential energy tu is converted to kinetic energy. So, I know that for B, all the delta U is now converted to K. Okay. Okay, disebabkan energy adalah skala, so we'll only take the magnitude nilai saja. 1.60 times 10 to the power of 2 equals to K, I know is half mv square. So, I need to find the value of V lah. Velocity of the probe of mass bila jatuh. Okay, so Miss pun masukkan lah. So, mass is obviously mass of the probe lah, bukan mass of the planet sebab dia yang bergerak. V square, so your answer should be 56.89 ms negative 2. Okay, so take note kan dia square root kan, so jawapan dia possible lah plus minus. Okay, tapi dia minta speed which is always positive lah sebab kita tak consider direction, so you need to put a positive answer. Okay, thank you. Oh, sorry. For example 9, try to do it on your own because it's very simple. Okay, thank you.